All right, so quiz 3. First problem, it says draw the mechanism and resonance arrows to form two different carbocation intermediates. A lot of folks recognize this resonance arrow piece. It's really important. So the first step is pi bond reacts with H+. It has to be this pi bond too, because these pi bonds are in the aromatic ring, so they're not going to be very reactive unless there's a super electrophile, and H+ isn't quite a super electrophile. So the first step, form intermediate A, secondary benzylic carbocation. We have the addition, deprotonation. That gets us to this product. If we had intermediate A, we could also do a resonance form, however unlikely, because this is pi bond is going to move there. Make a tertiary carbocation, but by doing this resonance, we've also disrupted aromaticity. Right, so this intermediate is no longer aromatic. We can still do the addition of the solvent. The oxygen reacts, adds in, we do a deprotonation, we form intermediate B. If you're thinking in free energy terms, B is both the higher energy intermediate, higher energy product, sorry, and it comes from the most high energy pathway. So it's not very likely either way. Whereas this one is the most stable product, so thermodynamic product, and it comes from the lowest energy pathway. So it's also the kinetic and the thermodynamic product. So the kind of the key here, and of course you have to have balanced charges, was really kind of taking that second layer of, do you remember how important aromaticity is for stability, for kinetics and thermodynamics? And of course, it's totally reasonable that one thing can be both the kinetic and the thermodynamic product. So the second question here is draw the product and mechanism arrows for the reaction below. It's worth 15 points. So we have excess of Grignard, and we have this carbonate. So this is something maybe we haven't seen before. It's kind of like a diester, a carbonate. But the rules still apply. When we think about when we have an addition, adds in, to make a tetrahedral intermediate, we got to ask ourselves, do we have a good leaving group? And we got to keep adding stuff. We're going to keep adding stuff until we don't have a good leaving group. And then we go to the second step. So notice, right, there's going to be a minus charge floating around here, and that's okay. These are two separate steps. We protonate everything at the end when we're done, not in the meantime. Some folks try to like mix these steps up a little bit. Just wait until the very end to protonate. So we do their first addition, tetrahedral intermediate. Do we have a good leaving group? We do. Elimination. Now we've made an ester, so now we're back to what we've seen before. Add another Grignard in, tetrahedral intermediate, kicks out. Do the elimination. Now we have a ketone, tetrahedral intermediate, addition, and now we have no other good leaving groups. And because we have no other good leaving groups, now we do the protonation. We protonate everything at once, and we get to our product, this tertiary alcohol. Other thing people goofed up on, they had lost the fact that this was a carbon there. They might have lost some carbons. There's a carbon there, so make sure you keep track of those carbons as well. Don't mix up the steps. Protonate at the very end once you have a tetrahedral intermediate and no good leaving groups. The bonus, indicate what hybrid orbital each lone pair is located in. Is a molecule aromatic, anti-aromatic, or non-aromatic? So because this carbon right here is sp3 hybridized, this oxygen can't do resonance. It's not next to a pi bond or a carbocation. So both of these lone pairs will be sp3 hybridized orbitals, and this oxygen is sp3 hybridized. And because this carbon is sp3 hybridized, this can't be anti-aromatic or aromatic, so it's actually just non-aromatic, right? Aromaticity, you need an uninterrupted p orbital system in a ring with an odd number pair of electrons. So this is not uninterrupted. There's a sp3 hybridized atom there, so this is not aromatic, and these are both just sp3 hybridized because they can't do resonance.